MCP, Model Context Protocol. I'm pretty sure that you've heard this term somewhere around the internet, and for a good reason, because it is trending in the AI space. So as a curious developer myself, I spent the last 48 hours doing a thorough research around MCP. So in this video, we'll talk about what is MCP, how MCP works internally in both client and server side, how to build our own MCP server in Python from scratch, and how to build our MCP client in Flutter, that is Claude Desktop clone in Flutter from scratch. So a really short note before moving further in the video, if you find these types of videos helpful, then please consider leaving a like and subscribing to my channel, as it really means a lot. So with that being said, let's first understand what is MCP. MCP, or Model Context Protocol. Think of it as a standard connector for all AI models, and the connection can be between your database, your tools, your APIs, web app, resources, your Python code, all of that. A great analogy I think of MCP server is USB-C cable. USB-C is just a standard cable to create communication between laptops, mobiles, display, monitor, and the Type-C cable helps bridge the two-way communication between these two devices. Now, taking this analogy back to our MCP server does the exact same thing. It acts like a communication bridge between your database, tools, resources, web apps, back to your LLM, now becoming a standard plug-and-play system for all AI models like GPT-4, Claude, Mistral, and even any model that comes next week. The only purpose of the MCP server is giving the LLM the ability to access these external tools, data sources. So now that we have a little bit understanding of what is MCP, and it's becoming a standard protocol for these introducing external tools and data sources into the LLM itself. But you might be wondering that how the hell this works. I mean, how LLM gets to understand all of these different MCP servers. Like each MCP server is using a tool which has its own authentication, its own documentation, and different tools require different parameters to be passed. So how LLM exactly knows which parameter to pass, what's the authentication, and what's the authentication process, how the documentation for the entire tool is written. So to understand all of this, we need to understand how MCP works. So how does LLM actually understand to connect with these multiple different data sources with different authentication, different parameters, different response structures? Well, to tackle this problem, MCP introduces a way developers need to follow, or these rules that developers need to follow while developing any MCP server, so that it can further communicate with any MCP enabled chat interface like Claude Desktop. So for example, at the core of every MCP server, it should always return the defined schema of the MCP client. For example, for all the defined tools, the schema should look something like this, because this is how MCP client applications can understand these tools, and all of these tools can be registered with the LLM and the MCP chat application. So LLM exactly knows what are the parameters required for this particular tool, and using these annotation properties, the LLM gets more insight about the tool. For example, if the tool performs any destructive updates like database deletion, then things like that LLM can understand. Alright, so now that we have a basic understanding of how MCP introduces all of these standardized approach of exposing tools, resources, data sources from MCP server to a MCP client. And the MCP client can further fetch all of these information, load the tools, resources in the initial system prompt, so that the LLM can be aware of all of these tools that it can use to actually do all kinds of different stuff. So now that we understood how MCP works, I guess it's time for us to see how we can build our own MCP chat application that is a Claude clone built entirely in Flutter. Let's move on. Alright, so first of all, let's quickly talk about the entire folder structure and the architecture we have in the front end. So we are going to follow the monorepo ideology in this video. So as you can see that we'll have our apps folder, which will have our Flutter MCP app, and next we'll have our packages. So here is where our main code, that is for example screens, will be inside our main app, and we will have all of these packages, for example our core shared utility classes, our data sources, our entities, repositories, our block state, our widgets. All of that will be segregated in these packages, and this is called as monorepo. That is, we will be using the Melos package for this, and in one mono repository we are going to have all of our packages and our apps in a separate folders, so that we can independently work on each package in the future, and it will result in less tightly coupled code. Next, we have our external folder, which is going to be the LLM kit, where we will have all of our Gemini API. So for this, I have used the Google Generative AI. And since that package is deprecated now, what I've done is I've forked that package and added all of the logic here, so that we can build on top of Google Generative AI and add more AI models, because that package only supports Gemini. So we can add more APIs and AI models, so that we can easily incorporate the LLM kit local package inside our Flutter MCP app. So that's it. And regarding the packages, as I said, we'll have our core utility classes. We will have our data sources, where all of the backend stuff, where in our case it will just be a local storage data source that we'll use here. Inside the entities, we will have all of the entity classes that will be required, that we'll talk about. Next we have is the repositories, where all of the connection between our data sources and our use cases, as well as the serialization and the deserialization, also happens here in the repository. Plus the LLM kit utilization, the LLM kit logic is also written in repositories itself. The state will hold all of our block classes, block qubit classes. So in this video I've not used block, so all of that is written in qubit and states, so that we'll talk about. And next we have is use cases. So all of the use cases that we have will be stored over here, that will be in contact with our block state as well as our repositories. And we have our widgets. So all of the common shared widgets inside our application will be stored over here, which we can use quite easily. So that is the folder structure that we'll be focusing on. Let's move on to the IDE, Android Studio, and let's see how we can build it. Alright, so as you can see, we are on to our Android Studio, and this is the Flutter MCP project. Now, as we've talked about earlier as well, that we are going to focus on monorepo, and we'll use Melos package for this. Also reflects in our folder structure, but let me just move on from folder structure to project source files, so that we can clearly see that we have our apps, external and packages. And if I go open that inside our Finder, you can clearly see that this is the entire folder structure. Now, initially, what you need to do, we need to make a YAML file first. So here in Android Studio, as you can see that first of all, we have our melos.yaml file that we need to make inside our root directory. In our Flutter MCP folder, inside the root, we'll have our melos.yaml, and here we'll just specify our repo name and our packages. So we'll have our apps, packages and external. We can even add tests that we can run automatically inside our melos.yaml. Next, what we are going to do is we'll have our pubspec.yaml file. So just create a pubspec.yaml file, and here add the name of the project, the environment, and inside your dev dependencies just add Melos. So to make this, simply create a folder first and then add these two files, that is melos.yaml and pubspec.yaml, inside your root folder. Next, what I've done is I've created this kind of folder structure. That is, we added these three folders that we specified in the melos.yaml as well. So apps, packages, and external. So I have added all of these right over here. As you can see, apps, external, and packages. Right. And simply we have to create all of these packages using Dart. For example, right now I'm in the terminal and I have this Flutter MCP folder. So I am in the root folder. I can ls and you can see that we have our apps, external, and packages. And what I can do is, if I want to add a new package, I can just change my directory to packages, and now you can see all of the packages over here. If you want to make another package here, just use the Dart CLI. So Dart create, and the template can be of package, and just name your package something like Flutter MCP blah, right? Just enter that, and there we go. We will have another package added right over here. So as you can see that it is not yet shown here inside our left panel, and reason for that is it is not yet integrated in our app yet. So Android Studio is not reflecting that. But if I go back to our folder structure and go inside our packages, I can see that our Dart package is successfully added like any other package over here, right? So that is how you can simply add new packages inside the packages or any other folder as well. Similarly, the LLM kit we have added. So all of these are nothing but Dart packages, and we have our pubspec.yaml for each package here. So you can see each package has its own dependencies and all of that. So let's first cover up our apps. So inside the app we have only one app. The cool and interesting part of using Melos is that if you are having multiple applications, then what you can do is you can use the same components, same logic that you have written in your packages, and utilize them in different kinds of applications. So you don't have to repeat yourself in multiple applications. So that is what I've done over here. But right now in our case, we are building a MCP client application. So we only have one app. Now let's open up the lib folder, and here we have a directory structure where we are specifying the DI, that is the dependency injection, and pages inside our application. Let's cover up our pubspec.yaml, and as you can see, I have specified all of the dependencies here that we are going to use. And interestingly, all of the packages that the app depends on, either locally, we need to specify them. So as you can see, all of even the external and the packages here that I have locally, I have just added them right over here inside our apps pubspec.yaml file. Now, interestingly, if you're wondering that we don't have a path here, why is that? So the reason for that is usually when we add local packages in Flutter, then we need to specify the path. But because what Melos does is we can simply run, let me go back to the directory, and after adding these local packages, we can simply run Melos bootstrap. Okay, I bootstrap. Yeah. So what that will do is it will connect all of your packages with one another based on the dependencies, right? So as you can see that Flutter MCP core is the package use case that is in the package MCP core. So it is checking for all of these packages that we've added, and it is trying to locate them based on the melos.yaml file. LLM kit is found in the external folder, entities is present. So all of the packages that we required are going to be added for us automatically, and it will generate the IntelliJ IDE files as well. So if you see here inside our root folder,
it adds these IML files which will help Flutter to actually identify that particular path of that local package. So that is how we are simply adding these packages, and how we are utilizing them is right over here. For example, let me open up any page. Let's go to the chat screen, and you can see that we simply import our Flutter MCP widgets. If I uncomment that, you can see what all widgets we are utilizing. For example, I added a custom icon button that we are utilizing right over here. We pass our icon color on tap. So all of these custom components are coming from our Flutter MCP widgets package, right? Cool. So let's go over here and let's cover up our Flutter MCP first. First of all, as you can see, we are using our getit package for our dependency injection. So all of the qubits we are assigning here as a singleton so that our instance remains the same, and same we are doing for our use cases as well. So we are initializing all of our use cases, we are initializing all of our MCP use cases, we are initializing the use case for chat, then we are initializing our repositories, we are initializing our data sources, and then we initialize our shared preference. That is the instance of the shared preference that we use to actually store our API keys and the MCP tools. So all of the dependencies that we need in the entire project, we just initialize them using getit, and this init di is getting called in our main.dart. So let's cover that up as well. Now here you can see that inside our main.dart, first of all, we are utilizing this window manager package, right? So how this is getting used is, if you go and see the application that we just saw in the intro as well, this is the Claude app. As you can see on the top left, this is the Claude one, and this is the Flutter one, right? Looks pretty much similar. We'll talk about a few differences as well, but we use window manager to specifically remove the title bar here and change the properties of the title bar, because you see that in a usual Flutter application, I'll put up an image, but the title bar, the Flutter adds a title bar over here that we can use to drag a window. But what we are doing is we are removing that particular title bar and even adding properties so that we can set Flutter widget right over the left of our traffic lights button, as you can see Claude has as well. So that is what I need to implement it in Flutter as well. So what I've done is, here you can see I've passed some window options, and that is we have to make the background color as a transparent, we have to skip the taskbar, change the title bar style as hidden, so we need to hide the title bar, and set our title as empty string. And when we are ready to show, then what we do is we show our window manager.show and focus, we call that, and we adjust our traffic lights. Why I added this? Because window manager does not allow us to adjust the traffic lights. So if I hot restart the application now, what you can see is in the Flutter app, there is no way that we can actually adjust the traffic lights. So I need to close the app and run it again. But what happens is Flutter and usually Mac apps put the traffic lights immediately on the top left, but we needed some padding. So that is why I added this adjust traffic lights function that we call to add some padding. I'll tell you why it is just going down and down, because every hot restart that we do, it is telling the window to push and add some padding. So let's go more in detail about this adjust traffic lights, what is happening. So I wrote a method channel here known as adjust traffic light that we are invoking. So let's go to our iOS folder, our Mac OS folder, and inside our runner app delegate.swift file, we have our method channel that we are registering, which is looking for our method as adjust traffic lights, and which adds padding of 12. So every hot restart, what it is doing is it is adding a padding of 12, right, to the traffic lights, because that is what we wanted. If I close the app and run it once again, what happens is, so as you can see that it adds a padding of 12 from the top here in the window. That's how we can use it. Let me just put the window over here. Perfect. So now we can see. So here we are specifying the padding of 12. And if you are wondering, this adjust traffic light padding, this logic is written in our main flutter window.swift file. So if you go here, I have made a few changes that is away from nib, and that was initially added by Flutter itself. What we need to override one more is we need to override set frame. So whenever set frame is called, then we need to adjust the padding. This is helpful because whenever we resize our Mac OS window, what it does is whenever we are resizing, it calls this override method of set frame and basically checks that the padding still remains as 12, right? And over here we are utilizing the adjust traffic light padding. That is what we are calling here as well, window adjust traffic light as 12. So initially we set it as 12. Right over here we have the logic written as this. So we simply check the close, mini and zoom, and all of these buttons we simply add the set frame origin, and we change our y axis of the origin for these buttons, and we change that over here. And next, the set frame is utilized whenever the user is changing the size of the frame. That time we simply needs to make sure that the padding remains the same. So that is how we achieved this traffic lights to come in a little bit below and added padding. And after removing the title bar and making the style as hidden, what we can do is inside our chat screen. So as you can see in the main.dart, we don't have any complicated code. I am just initializing our get_it dependencies, and I added this talker block. So if you see our pubspec.yaml file, what you will find is, okay, let me open that again. Pubspec.yaml file, you will find that I've added talker block logger package. What that does is, if you are using block state management, talker block is really good in actually printing out all of the logs. So let me hot restart, and you can see all of the block logs we can see very clearly over here, right? So we can see that settings block was created, chat qubit was created, and we are seeing all of the transitioning from the states. So the chat qubit state was updated, right? And we can even update what we are printing in the state, exactly like what properties were updating. We can even print that over here. So this is a very handy package for us to log all of our state changes, all of the transition, and how block is interacting with our application. So it makes debugging very easy. Next, we are simply utilizing di object to initialize our sync connection method. So what it does is it connects and disconnects our server that are stored locally. So using our get MCP server use case, we are fetching all of the MCP servers that we have already initialized locally. And if we have any server present, then we simply connect with that server using our connect MCP server use case. That should be over here. So as you can see, for each servers to connect, we simply connect with that MCP server by calling our use case, and passing in that MCP server configuration that we are getting from servers to connect and currently connect, or from our desired active servers, which is basically coming in from our server config result that is from our local storage, right? So that is what initially, whenever the app launches, we connect with our MCP server. So if I go over here, and you can see that right now it is showing as no MCP server connected, but we can click on that and we can easily connect any MCP server and add it inside Claude. As you can see, I can click and we have a MCP server already added in. So we'll add that inside our Claude desktop, inside our Flutter app as well. But first, let's talk about the build method here. So all of the blocks we are initializing, that is our settings qubit, our MCP qubit, and our chat qubit. And we are calling in the initial methods as well, that is load the initial settings. What are the initial settings? Like the API key and our MCP servers. We have to listen to any MCP updates, so we are calling that, and we are initializing our chat qubit as well. So all of the initialization is done right over here, and we are utilizing the get it dependency injection. So same instance is being utilized for this, all of these block that was initialized in our dependency injection. And next we are using our route. So in this application we only have one route, that is ChatPage, that is our default page. So that is what we are using. Now here, first of all, in the interesting thing I'll show, let me just move this. Yeah, send message, scroll to bottom, show snack bar, and body. Yep. So what happens is, right now we have our build method, and inside here, as you can see, we don't have any app bar, but we need this button. Let me just start the app again to fix the sidebar issue. All right, so our app is launched. Let me just put it over here. So what I was saying is, inside our main build method, inside the scaffold, what we are doing is we have our basically these widgets specified. Let's talk about the first one, that is the title bar. So the title bar here contains basically a column where we are specifying our sidebar SVG. What we've done is we specified the height of 12, and if you remember, that is the exact same padding that we passed for our button traffic lights as well. So the same padding we are passing for our sidebar as well. Because we specified the title bar size as hidden, we can directly start our widgets from the very top, right? So we don't have any title bar initialized. So I just added our sidebar SVGs. All of the icons and the SVGs are available in our assets folder in our main application. And these icons are, I have basically downloaded them from the Claude website, so that everything remains exactly the same, since we are copying the Claude desktop application. So you can see all of the icons look exactly the same. So I add our sidebar, and next we specify that if the messages are not empty, so we have message, then we simply specify a untitled text. For example, if you start chatting with any chat application, you see the title, a summarized one-liner title of that conversation. So for now, we just specify untitled here. I'll show that. And if the messages are not empty only, then we will show that title. Otherwise, we don't show anything. And then we have our expanded, where we are using our gesture detector, and we use this method called as window manager.start dragging. So on pan start, so what it does is this entire expanded widget acts like a draggable. So we can convert our gesture detector widget and we utilize our start dragging method over here to make our window draggable, right? If we don't do that, then we won't be able to drag our window, since we have removed our title bar from the Flutter app, right? And then we just use the sized box since it is expanded, so the sized box is completely taking the entire space, and the gesture detector uses the start dragging method to makes the entire window draggable. Next we have our add icon. So for example, if I start any conversation with Claude, let's say hi, so what happens is, first of all, it is loading, so let's wait for that. One thing I noticed that Claude takes a lot of time to load as well. I'm not sure if it is just me, but yeah, Claude takes a lot of time for any chat conversation or anything. Okay, let me just show that same hi in the app as well. So let's just say send, and there we go. We are using, so what I was saying is, inside that, in the top, Claude also adds the title as well as this icon, the plus icon, so we can clear the chat and start a new chat. So that is what I wanted to show, but Claude is still just loading. I am not, but okay. Let's go over to the code, and here we are assigning if the messages are not empty. Since we had our messages, we can see our add svg, so we are using our custom icon button, which is coming from our Flutter MCP widgets and common icon button.dart, and we can specify our icon color, and we can specify on tap. The show border is used to actually show the outline border, because I saw this theme that Claude uses this border around the icon buttons, around the text field. So I created a extension, and we can use that Dart extension by just passing in this variable as show border or not. Next, that is the first widget that we had to talk about, that is our app bar. Next we have is the divider inside our title bar as well. But next let's go and check out the expanded widget, which is the entire like this expanded widget. Initially, if the messages are null or empty, then we just show our centered widget. So let's go and open that up. We can find our servers, our MCP servers from our setting state. We can get our server list, and from our chat state we can find our display messages. Now if our chat status is initial or loading, we specify a circular progress indicator. Otherwise, if it is empty, then we showcase our center widget that you can see right over here, this text field, this text, everything, and suggestions. Otherwise, we just show our list view where we show all of the messages. So let's go to padding, and here you can see that first of all we have our free plan chip. That is the free plan chip. That is also coming from our Flutter MCP widgets. Next we have is our logo, and this is the logo and the text, right, that Claude also shows. So let's come back to our app, and we have our logo and the text. So that is inside the wrap. Next you can see that we have our text field. So over here we have this entire text field that is also coming from MCP widgets, where we are passing if the text field is enabled or not, if it is loading, is it applying. So initially all of that is false by default because we are on the initial state. Enabled is true, a controller we are passing. Connected count we can pass, so how many servers are already connected. The API set, is the API set or not, we can pass that. And we can pass our on modify and send. So on sending the message, this method will be called, and so on modify means that on clicking the modify icon button, this showed a dialog we are calling and opening up this dialog box. Otherwise, inside the send message, we are simply using our qubit and calling the send message function, and passing our message that we need to send. So that's about it. Let's go back to our widget. Next, we have our wrap. We are using wrap and all of these suggestion chips and all of these chips and SVGs and labels we have taken from the Claude Desktop. So I've added that. Next, you can see that we have our list view builder. So we are passing in our messages, and for each message we are rendering our message bubble, which is also coming from our Flutter MCP widgets, as well as we are passing in our server configuration so that our message bubble actually showcase the server information, like the MCP server or tools that was used, right? And at last, what we are doing is we are using the same chat text field again. If the messages are not empty, then we show the bottom chat text field instead. So that is the code. Same on modify and send message callbacks are there, right? So that's pretty much it inside our chat screen. Now let's go to and let's add first of all our MCP server. How you can add it is pretty simple. So I have this MCP server that we can add. So all of the information I'll explain later in the video and how we can build this MCP server. But to add it, we can simply click on add. We can pass in the MCP server name. We can pass the server a command that is UV. We can pass the arguments. So we'll pass the run arguments. We'll pass it connect automatically, and the environment variables we'll set our API key right over here for our Brave. So this MCP server that I'm adding in is for the Brave API, so that this MCP server will enable our LLM to use internet and search on internet and find more details using this MCP server. So let's add that in and let's quickly enable that right over here. Right now it is disconnected. So let's try to hot restart it. And there we go. You can see that one MCP server is there right in the app. I can click on that and our MCP server is connected. Now what I can do is I can simply say like hello, and we can simply chat. And next I can say like can you tell me about Met Gala 2025, for example. So now as you can see, it is thinking. It got the result back from the Brave web search tool, and now it gave us the result back. So that is how it started thinking. But initially if I just say good, it won't think because it knows that it can answer on its own. But if I ask something else, for example, any news, what are the latest LLM models that are launched? Then what it does is it started thinking using the Brave web search tool, and then it will prepare our result and then give us the result back. So that's the MCP server and tools acting in. Let's go back to our code and understand how this works. Right. So the best way for us to understand is to go step by step, and first of all understand whenever we type hello and click the send message button, let's go to the flow one by one and understand how we are sending the message with our MCP server. So as we can see in our front end, let's forget about all of our packages and external for now. As we encounter them, we can look more into those, right? So let's go to the send message. First, we are doing some basic validation, like if the API key is set or not, or if the text is empty or not. So we are doing these basic valuations. And then what we are doing is, if we go back, if we go in the bottom, We are simply first of all adding in our chat message inside. We first of all create our current message list from our state.display message. So whatever messages that we are displaying right now, we have to add another user message to display. So we are adding that. And next we are adding one more message that is from the AI side, but that one is empty right now and that is not user. So we are specifying that as well. And next we just emit that with the current message. So the state is updated and we can see our user message onto our screen. Right. Next, what is left is to send that message. So we prepare our parameters that we need to pass. That is the chat history. So this chat history and the display messages are different because display message is representing our list of chat messages. That is the front end chat messages. But this chat history represents this AI content, which is present in our entities package, which holds in all of the information like the AI content which needs to pass on to our Google generative AI package, or in our case LLM kit package. So this chat history and our display messages we are passing in. So inside our send message parameters, we pass the prompt that the user is asking and the chat history to our send message. So we call our send message use case, and then we are using either in this entire package. So if you know that we are utilizing the Dart-Z package, and using the either, we can fold that and see if we have any error or not. If we are folding towards the left side, that means that use case encountered an error, and we can tackle that accordingly, and we can handle that error in the left side. But on the right side, we are getting a stream. So what this stream represents is, as you can see in the bottom, what we are doing is we are copying the stream.listen, whatever like tokens response that we get from our stream, we are utilizing that. And this update is nothing but the stream is of sendMessage update class. So I've added a extension on stream message update, that is the stream message update matcher. And here basically it returns, like it takes in few callbacks, that is on chunks, tool call, tool result, final content, and thinking. So based on that, we can emit the state accordingly if we are still chunking the result, if we are calling a tool, if we have resulted a tool response, if we are on the final content, or if we are thinking right now, right? So all of these callbacks that we can run in, what it does is it just checks on the type of sendMessage update class. So it is an abstract class that we are implementing in these different classes. For example, sendMessage tool call, it is implementing our sendMessage update class, and it takes in the basic arguments that are required for that particular class. For example, if we are sending message tool call update, then we need to pass in our tool name, our server ID, tool arguments, and the server name. Right, so all of this information can be passed to the front end. So the front end exactly knows that in this particular state we are calling a tool, the tool name is this, and that is the arguments that we are passing into the tool, right? So that is how, if we are on the tool call state, we get all of these arguments like parameters, and we can emit our state accordingly by simply updating our last AI message as thinking, and we pass all of the information as well, so that our front end can easily reflect our tool information as well. Similarly, we are using chunking. Whenever we are chunking, we set our chat status as message streaming, and we update our last message as our updated response buffer. So this response buffer is coming in from here, which is a string buffer, so we can increment and add more tokens as we are streaming in the response, right? And this is the final content. So once we have received our tool result, then we think on that tool result and make a final response. So once we have received this final response, then we simply call this final content, and here we update our last message with our current message. So you can see that is what we are updating right over here with the final text message, right? And if we get any error, we just simply log that here, like chat qubit error in message stream. And yeah, if we are done with that stream, so basically this is for the stream part, like where we are using the stream.listen. We have this on error and on done, so that we can quickly dispose our stream as well if we are getting any errors, and we can emit our states accordingly, right? So that is what we are doing inside the send message, but we understood how we are listening for the message. But let's go to our send message use case and let's understand how we are getting this stream. So we are making this stream controller and we are passing in the controller.stream over here. But inside the execute send message, this is where all of the logic is written, where we first of all check the API key, and based on the API key we check if it is initialized or not. So from the local storage we basically check if we have the API key or not. That is why it is using await, because shared preference internally use await. So inside our AI repository we have a future bool of getter is initialized, and it's in its implementation we are basically getting a client, and inside here we are getting in the API key and checking that if we have the API key or not. If we have that, then in the right of that fold, so here also we are using either, and we basically just specify and return our AI client that we specify here, right? So that is what we update our client using the Google generative AI client. And yep, we update our client and we result our client back. So if we are not having our API key locally, then it will basically give us an exception, which will call in our exception over here, and is initialized will be false. So we pass in that we don't have our API key yet because our AI service is not initialized. All right, let's move on. And next we basically check in the MCP state. So inside the MCP state, we have our discovered tools. So all of the tools that we have at our disposal, their names, description, their schema, all of that is defined inside our MCP state, as well as the active MCP servers connections as well. So what we do is we first of all check the use MCP if we need to use MCP or not. If we don't have to use MCP, we simply call our stream direct AI response, and using that we can simply stream out the AI response using the Google generative AI. So let's just go here, and you can see it is basically calling in this send message stream, which is the response stream, and we are simply yielding each chunk of the token, and we are updating our send message chunk update, which is implementing our abstract class as we just look earlier, right? And that's pretty much it. Yeah, once it is completed, then we result back as send message final content update, and with the final content, so we can update our front end. But if it is a orchestra MCP query, because if use MCP is true, then what we do is we call our orchestra MCP query method, and here we first of all get all of the tools that we have at our disposal. So how do we know if we have to use MCP, if we have any discovered tools or not? So right now, as you can see, we have our MCP server added in, and we have our MCP tools integrated as well. So we are calling in our MCP orchestra method. So we are orchestrating a MCP query with the tools integrated. So if we go over here, you can see that first of all we get all of the tools from our MCP servers that we've added in, and then from these tools we map that as AI function declaration, basically passing in the AI schema, the description and the name of that tool. So from that tool we create these function declaration. Why we are doing that? Because we need to pass that inside our API calls, because if we do not have a tool inside the MCP server, then we simply just call in that no tools available answering directly. So we are thinking that, and then we just return a final content and return that. But if we do have tools, then we first make our agent conversation list, that is all of the past messages as well as the user message right now that the user added the message, and then we message the fine like planning approach. Now what we do is all of the tool that we have at our disposal, this agent AI tool, we pass that inside our tools, that is generate content, and we return our AI response from here. So based on the provided tools, we can pass all of those tools here and we get our response. And using that, right now as you can see that the agent is thinking and the iteration count is 0. So we keep on thinking until we get like our result that the agent is looking for. And once that happens, then we can simply break out of here, right, this iteration. So we can simply break out of here. But let's see the agent conversation, and we are processing our tool calls. So we pass on our tool name, tool argument, tool entry, all of that, and then we can simply use our MCP repositories.execute tool, and we can execute our tools. If our LLM finally decided to use any tool, for example, if it decides to use Brave API to search on web, then using our repository, we execute our tool, pass in the arguments that LLM gives us, and then we get back our result that we can utilize inside our AI function response part, right? And once we have our function, then we pass it back to our sendMessage tool result update to update our our state inside our front end. And yeah, that's how like the agent thinks. And once the loop ends over here, then what happens is, as you can see, like once the loop ends, then we need to send our final message based on all of the context that we have gathered. So please provide the final answer based on our conversation. We are passing that agent inside our agent conversation. So we get our final response by calling in the generate content function, and then we call in our send message final content update. So that is how like we are utilizing these MCP servers. We are fetching it all of the tools that we can use, and based on the tools, LLM first decides inside our loop if like it basically thinks and gathers all of the information by simply executing these tools, right? So it executes all of these tools and gather the information basically by appending inside our function responses, and from the function responses we update our agent conversation again, so that finally we can add all of the thinking that we did back to our agent conversation, again generating a final result that we can return to the user. So if you think about it, MCP servers are nothing but calling in or the MCP server, fetching the tools, and using the tools, registering it in the LLM, so the LLM knows that I can use these specific tools, and then LLM can think which tool to use, and then it can execute the tools to get more context loaded in, and then finally we can call in our final response and generate content. So that's pretty much how we are utilizing this MCP server inside the client side, and we are calling the send message. Let's talk about quickly inside our modify how I added these information. How can you also set up your own MCP server and quickly add it? So if you see that this MCP server is running locally, so let's open up our cursor and see how I built this MCP server using fastMCP, and how you can also integrate that in your Flutter application. So let's open up our cursor, and yep. All right. So as you can see, the code is pretty simple. First of all, inside the requirements, we will need Pydantic, HTTPX, and fastMCP. Let me make it a little bit bigger so everyone can see. Right, fastMCP we will use to build our MCP server, and inside our main.dart code looks pretty simple. So what we are doing is we are using this fastMCP. We are getting in the API key. So whenever we are initializing our server and calling it from the client, what client does is it will run our server and pass our environment variables. So as you can see that inside our Flutter application, I set the API key variable and set it to my Brave API key that I need to use. So that is what we can simply load the environment from the API key. You can see that I don't have a .env file, but it is taking in from our MCP client itself, and I just log that API key for my own sake. But yeah, let's leave that, and let's go to the bottom, because here is where you can also run your MCP server by just calling in the mcp.run, and we have two tools set up. The first one, that is the Brave web search, and second one, that is the Brave local search. We need to focus on is this one. So we can make a tool by simply specifying like @mcp.tool. So this decorator we can use to convert any function here as a MCP tool. We can pass in our query, and we can set our other parameters that LLM can pass in. So query, count, and offset that LLM can pass, and we add these description so that LLM understands what this parameter is about, right? Next, we pass in our doc string, so LLM gets more understanding about the tool and how it can use it. And finally, we just call in our perform web search, pass in the query API key count, and we call our API to fetch the information from the internet using the Brave API, and then fetch the results. So here is where we are using the Brave API, make the HTTP requests, and we are parsing that response and returning back our formatted result, the title, description, URL. So the LLM can easily understand and get more context. So that's pretty simple. Now once if you try to run it, let's try to run it. You can see that our MCP server started. But if you want to test it, what you can do is just run fastmcp dev main.py, and what that will do is fastmcp dev main.py is it will start the MCP inspector at your local host 6274. So let's open that up, and here you can see that we have our MCP server, and we can connect to our MCP server from here, and we can see our tools. So let's try to list our tools. There we go. We have two tools available, Brave Web Search and Brave Local Search. We can get our resources, prompts, we can ping, we can get our sampling, routes. So all of the MCP inspection and test as well, we can clearly do from here. For example, this Brave Web Search, I can test this tool. For example, tell me some latest news in India, and I can run that tool. It requires API key, so I need to set my environment variable over here. So I can just add the API key. So I'm going to set our value, and let's restart our server. Now let's again say tell me some news about India, and let's run our tool. It's running, and there we go. We got all of the news updates from our API that LLM can utilize, right? So that is pretty much it, and you can see all of the history. We can track our MCP inspector over here, and this is a very basic script, but what you can do is, like, if I open up our fastmcp in Python, it's quite easy to build these MCP servers in Python. So all you gotta do is import the MCP instance you need to have, and just have your MCP tool by using this decorator, and you can run your MCP tool using fastmcp run, and even use the inspector available using fastmcp dev, and then your file name, which I ran over here. Yep. That is how you can run your MCP server in Python. And to integrate your MCP server, all you gotta do is whatever the server name that you pass, you can pass that here. Server command, you can set it as UV. Server arguments, similarly, you can pass as a run with fastmcp, with Pydantic, with HTTPX, all of the dependencies you need to add in. Then fastmcp run, and you can specify the path of the file that file exists in. That is our main.py file, and add in the environment variables, and that's pretty much it. And then your MCP server will be added in, so you can chat it inside using your Flutter application.
So that's a wrap. I hope you learned something new in this video. Subscribe to my channel if you are interested in app development, LLMs, and building agentic applications, because that is where the future is going to be. Check out this video where I built a Flutter agent application and integrate the agent workflow into Siri itself. Or check out this video because YouTube thinks that you'll probably like it. I'll wait. I'm kidding. I'm Yashmakan signing off.